Here's a high-level diagram of what we'll be building in this project. First, we're going to need to create the front end, which is the chatbot interface where you can see the old messages, as well as send new messages and receive a message back. Then we'll create an audio file using some APIs where we'll send the text response and create an audio file that can be played in the front end. Additionally, all the messages will have to be saved in some sort of database, and then we'll have to save all the audio files in some type of file storage. To do all of that, we're going to need to use some different frameworks to make all of this a lot faster. So on the front end, we'll use Next.js to build out the user interface, and we'll ship that to a accessible URL using Vercel. Then every time we send a message, it's going to hit an Amazon API gateway, which calls our Lambda function that holds the chatbot, and that uses LangChain and OpenAI to create a response for us. Once that function is invoked, it's going to do several things. One, it's going to update the user message as well as the chatbot message inside of the database, which is on DynamoDB. And then we'll also convert that text to audio using the 11 Labs API. After the audio is created, we'll save that into a file storage system, which is Amazon S3. And because I've mentioned a lot of AWS services, we'll also wrap all of this stuff in a AWS framework called Chalice, which allows us to use all of these services without having to manually set them all up. It's going to speed things up quite a bit. So first, we'll build the front end using Next.js. And to do this, simply use this command npx create next app at latest and hit enter, and basically hit yes and accept most of the default configurations. They don't really matter. I've already done this, so I won't do this. And then we'll create our application up above, which you can start using npm run dev. And I'll use node 18 for this to work. And Node.js should work. Okay, now that we've got our front end running, we're going to define the page header. So on the left here, we have a simple form with React. And this is just going to allow us to set the different options for our girlfriend, trainer, or therapist. It's going to let us select the different model. And it's going to let us select the different temperature for the model. On the right-hand side here, we have the chat messages. So the chat messages is just me passing the array of messages to this component and then rendering them all out. And then it's also allowing me to input a message down here and then submit that to the backend. I'll talk more about these functions later. For the backend, we'll be using AWS Chalice. So AWS Chalice is a serverless framework for building applications with AWS. It has 10,000 stars on GitHub, and it's pretty well maintained, and it works pretty well out of the box. How this is different from other API frameworks like FastAPI or Django is that this works straight out of the box with AWS services. So there's no need to add any additional configurations or convert your functions to Lambda functions, which can lead to many hours of debugging if you get like a single part of that process wrong. And trust me, this is from experience. As you can see here from their documentation, it's pretty simple to create REST APIs, but before you start, you will have to create a AWS account as expected. And they have some installation instructions over here for doing that, which I will skip for this video. But once you're in your virtual environment, whether that's the VNV or Conda, you can just run this command pip install chalice. So I've already got my env activated like this, and then I will just run the command pip install chalice, which I already have installed. And then I can use the command that they have in their quick start guide, which is this. and I'll just rename it to hello-world. So you can see that it creates this .chalice folder with your config.json. This is where you can put your API keys. In your app.py, it shows you how to create your first functions. So you can uncomment these lines out to create a route that can process the query. And you can also have things that can take the JSON body from a request. Then you define all your requirements in this requirements.txt file, which is needed for AWS Lambda to build your package. But for me, I've already set up most of the requirements in this other Hello World project. And basically, you can see here that every time you deploy your project with Chalice, deploy, and let me cd into my project and hit Chalice deploy, it'll start running all these deployment packages and create a new deployment zip file, which will get launched onto AWS Lambda. Additionally, this policyprod.json file allows us to set up services like DynamoDB, as well as the Amazon S3 bucket that we'll be configuring later. But the main file that we'll need to configure is this app.py file, which kind of reads like a fast API project if you've ever used it, where you start the app just using app equals Chalice, set up any cores, configurations, and then all your routes will be defined as the first parameter after you specify an app.route. So after the Chalice deploy function finishes running, the new deployment will show up in your deployments folder if you ever want to check what packages were included in there. And more importantly, you'll get this REST API URL so that you can put this function or this endpoint into your Next.js application. So here it's going to load the Lambda function after we hit this API. And it's just going to read this JSON body, which is the same as I've defined here in my app, not this app.py, but my actual app.py file over here. Okay, so we can change this to whatever we want. And just add a YouTube here, hit save, and since we don't want to redeploy this, you can always just hit Chalice local to see what it'll look like locally. And we can see our local changes here without having to deploy to AWS every time. So inside the requirements.txt file, we'll define all of our requirements, some of which are the Boto3, which is the Python SDK for using AWS. We'll use LangChain, as well as some OpenAI and other LangChain packages. So these are all needed so that your Lambda function can be deployed. So next up, we'll be creating the actual Chatbot implementation. So once the user sends a request to this URL, so the one that was up here, REST API URL/chat, it'll start all of this logic. So first, it's going to pretty simply store the messages, which I'll talk about later. But the main function that I want to talk about is initialize chatbot. So in initialize chatbot, we're just going to create an instance of the chat OpenAI model using ChatGPT 3.5 Turbo, which gets put in there, and we'll send in the temperature from the user. Then we'll create a conversation buffer memory so that the memory key can match the prompt template. And if you're curious about how the prompt template looks like, it basically takes in the history, which is the history of conversations from our database, the new user message, and then it gives a space for the AI to ask a question. So depending on what prompt template we pass in, whether it's a girlfriend, a therapist, or any other prompt template that we want, it'll change the prompt of our chatbot accordingly. Then we initialize a conversation chain, putting all of these things together. So putting the OpenAI model, putting the memory in, and putting the new custom prompt, and we'll initialize that chatbot. Going back to the route, so after we initialize the chatbot, we'll then invoke a message from it by passing the previous messages as well as the current user message, and then we'll return that to the front end. So the next thing that we'll need to do is create a DynamoDB table so that we can store all these messages somewhere. So this is a quick script that you can run to create a DynamoDB table. So basically, you connect to the Boto resource by specifying DynamoDB and making sure that your region name matches the region that you're in. And then we're just going to run this function and call it chat messages. And basically, this is just going to create a table in DynamoDB where we're going to specify the attribute name for the primary key, also known as the partition key, which will be those unique chat IDs for each user's conversation that they're spinning up. Then we're going to add timestamps so that we can sort by the time that the message was added to the conversation. And then we'll leave the rest of these attribute definitions and the provisioned throughput to their defaults for AWS DynamoDB. And finally, we'll create the table and print a message once that's done. So if we run this function by running this file, so if we run this file, it'll create this table, but I've already created this table, so I don't need to run it again. After creating the table, it should appear if you go to your console and then go to DynamoDB by searching it in the search bar, go into the chat messages table that is newly created, and then exploring the table items. So you can see here the chat ID, which is a unique key, and then the sort key for sorting our messages. Some of the columns include the audio file URL, which will be used to play the audio, the message from the user or the AI, and then the type, telling us if it is a user message or an AI message. Back in our Chalice application, we'll define a function called store messages, which will take the user message, tagging it with this message type, and then passing in the chat ID, the timestamp, and the actual message. And that's just a simple table put item in the DynamoDB database. Then we're also going to get all the messages for the chat. So that's another simple query to the DynamoDB database where it's just table.query, passing in the chat ID where it's equal to the chat ID that you passed in, and returning the items. Then we're going to do a little bit of parsing into LangChain messages, which is needed so that the LangChain conversation chain can understand our message format. So this is just going to convert all our chat messages and put them into this chat message history object from LangChain. Then if the user is able to get a response from the conversation chain, which is used up here when we invoked the chatbot with the previous messages, as well as the newest user message, we'll then convert that to 11 Labs with audio. 11 Labs is an API that allows you to send messages as text and then get an audio response back. So here are their pricing tiers. We'll just be using the free tier where you get 10,000 free characters per month, so about 10 minutes of free audio. And then you can get your API keys by clicking your user account in the profile icon down there and adding that to your Chalice application. So back in the Chalice application, you can add your environment variables just like this. So you can add your OpenAI key down here and your 11 Labs API key in here. And you can then define which policy.prod.json file will be used for your local host versus the final production application. So here is once again all of those rules that allow us to interact with our database table as well as our S3 bucket, which I will explain later. Back in the Chalice application, after we get the response back from the chatbot by hitting it with the chatbot.invoke, passing in the history as well as the latest message from the user, we will then create the audio using this function here. So this function is a simple API call to 11 Labs where we pass in a payload, which is a dictionary with these parameters. So first thing is text, which is just a message from the bot. Then we're going to pass in the model ID, which is just 11 Labs monolingual underscore v1. Then we'll pass a stability of 0 so that it'll be more human sounding, it'll have more emotions. And then similarity boost is having the AI sound more like the original voice. And so we're also going to set this to 0 so it doesn't try to mimic the original voice too much. It's just going to, let's try to sound as human as possible. We'll pass our API key as well as some additional settings, which are the defaults here. We'll also pass in the voice ID, so you can go to this link if you want to browse through their large selection of voices. And all you have to do is grab one of these voice IDs in the in this big list. But let's go back to VS Code. So all you have to do is send a request to this API endpoint, pass in the voice ID, and pass in the payload and headers, and then we'll return the response content back to the route. Next up, we'll need to create a way for us to store these audio files for the user. So we'll go to Amazon S3, go to our console, and go to S3 here to see all our buckets, create a new bucket, and we can accept most of the default configurations, so just enter a unique name here. And this has to be globally unique. You can set ACLs to disabled, block all public access, disable bucket versioning, don't worry about tags, don't worry about this, and just simply create the bucket. Your bucket name will show up here, which you can copy. And then going back to our application, we'll need to upload the audio that we get back from 11 Labs and put it into this S3 bucket. So here I've just created a simple file that creates some MP3 file name and then uploads that to the S3 bucket. This is a pretty straightforward piece of code. We connect to the S3 client, we pass in the bucket name, so whatever the bucket name was that you just created, and then we're going to use this io.bytes.io library so that we can convert it to bytes and then upload that straight into the S3 using the .upload file object method on the S3 client. Finally, if the upload status from the upload S3 audio function was successful, this will return true, and then we can create a pre-signed URL which allows us to play back the audio that we just uploaded into the bucket. So we'll get that link using the getS3 link function here. And this just requires your bucket name, how long it'll take to expire, so 7 days or 604,000 seconds. And then all you have to do is connect to your client again and generate the pre-signed URL method. So this takes the get object parameter, it takes in the bucket name and the key of the file, so the name of the actual audio file and how long it takes to expire. So by default, 7 days. So we'll add this as a parameter to the user message, and then we'll finally return all of that back to the front end. So now if I go into the S3 bucket, you can see all of the generated audio files with these generic names, but they're created as MP3 files. So we can click it, go to open.
Hey love, there are so many things I love about you, but if I had to pick one.
And so we can play the audio back and then get that pre-signed URL and pass it back to the user. Finally, just make sure you add the correct policies here so that you can access the DynamoDB table as well as the S3 bucket. So you'll have to add this name of your S3 bucket and up here the name of the chat history table that you created. So if everything looks good on the local deployment, then you can do a Chalice deploy once again, just like this, and it'll redeploy your application with the latest functions and put that onto AWS for you. So now we'll go back into the Next.js application and I'll show you how to link this up to the Chalice backend. So first we'll grab this endpoint, which we got from running the Chalice deploy command. In the last function, after the Chalice deploy runs, it'll update the IAM policy, it'll update the Lambda function, and then it'll give you a URL, which you can just copy and paste here. So now we'll create the function handle submit, which is defined down here. So when the user hits submit, it'll trigger this handle submit function. And all this is going to do is get the chat ID, create the current timestamp, and then update the state of messages that is shown on the screen. This is the most important part here, where it passes the chat ID, the timestamp, the message, the model, the prompt template, and the temperature all to the backend so that it can be processed. And you can see that here in the get chat response, where we get the app's JSON body, and then we access all of those chat IDs, timestamps, messages from the app.currentRequest.json body. Finally, we will pass all of that into the fetch method from Next.js. We'll get the response back and then update our messages on the front end. Another function that we'll need to define is the fetch previous messages function. So this will run at the start of the application or anytime the chat ID is changed. So fetch messages, we'll call this fetch messages function down here, which calls the same endpoint and calls the /chat/messages and passes the chat ID in here. So you can see here in the backend, the /chat/messages/chat ID will grab the chat ID from the function definition, and then we'll pass that to our getAllMessages function, which is a simple call to the DynamoDB table, passing in the chat ID where it equals the chat ID that the user provided, and we'll return all the response items. So that's pretty much it for the coding side, and we'll show you again how it works, where we can choose the new character. So let's refresh the page, and it should be able to fetch the last messages for us since the chat ID gets changed every time. We'll create a new chat. We'll select a therapist, and we'll set the temperature to 1, and we'll just ask our therapist what's up. So this is going to take a little bit of time because for simplicity, I've not added streaming, and additionally the audio does take about half a second to a second to create that audio transcription.
Therapist, hello, I'm here to listen. How are you feeling today?
To get our front end Next.js out of localhost and into this custom URL like this, all you need to do is go to vercel.com. Just need to create an account, link up your GitHub repository, and then go here and hit add new project. You'll just need to select the repository from your GitHub projects. So this is the one that I've uploaded to GitHub. And then you can add any environment variables. So for this project, you didn't need any environment variables. And then just hit deploy. So this will just take a couple moments, and then it'll give you a link to view your new website. So once it's finished compiling, it'll show you this green ready icon, and it'll show you this custom URL that it's created for your project, which you can visit over here. If you want to edit the domain name, you can just go back here, hit domains, and then edit the domain as you wish. So that's it for today's video, guys. And if you're interested in building more AI projects just like this, make sure to hit the link in the description where you can get notified when my course drops, where you can build tons of more AI projects just like this using LangChain, OpenAI, Next.js, and Python. And if you're looking for custom software development in the world of AI, make sure to check out the other link for my website down below, where you can get custom software development done in the world of chatbots, AI agents, APIs, or any other multimodal generative AI solutions. Thanks for watching the video, and I will see you in the next one.